So today I'm very happy to welcome Martha Farah. So she's going to speak in our British Association for Cognitive Neuroscience Worldwide Neuro, which is streaming on YouTube and also available there. I'm Jamie Ward, the president of the British Association for Cognitive Neuroscience. So Martha did her first degrees in metallurgy and philosophy, correct me if I'm wrong. So then she made this transition. Martha Farah. So she's going to speak in our British Association for Cognitive Neuroscience Worldwide Neuro. Sorry, I'm just muting it on YouTube and also available there. I'm Jamie Ward, the president of British So Martha is. Martha did her first degrees in metallurgy and philosophy. Correct me if I'm wrong. So then she made this transition. Okay, there we go. Sorry, we just had some feedback there. So Martha spent most of her career at the University of Pennsylvania, where she made a fantastic career as a neuropsychologist studying perception. Then she became the director for the Center for Cognitive Neuroscience before finally becoming the director for the Center of Neuroscience and Society, which takes up most of her current research interests. And today she's going to tell us about the neuroscience of SES and poverty. Is it actionable?
Great. Thank you. Should I start talking now? Great. Okay. Well, hello. Thank you very much for having me as part of this series. Today, I want to try out a slightly new way of framing things. So hopefully it will hang together. If not, feel free to interrupt with questions, give me questions afterwards. But the question I want to address is the neuroscience of SES and poverty, is it good for anything? Does it indicate things we can do to reduce the harms of poverty? Whoops, let's see, can I advance this? Here. Okay. Sorry. One thing metallurgists don't learn is anything about, IT, electronics, computer science, etc. Okay, can I do that? Yes, okay, good enough. I will do that. So why should we care about whether this relatively new branch of science is applicable? Well, the obvious reason is that SES is linked to many outcomes that we care about that have some moral weight to them. One thing is it's linked to mental health. So here's just one example of findings from some Canadian epidemiologists who screened a large number of people, divided up into income deciles, screened them for symptoms of depression, and looked to see which ones report symptoms that would qualify them for a diagnosis of major depressive disorder. And you can see that the, you can see that the people in the lowest 10% of income have 14% of them that year experienced symptoms of depression. I mean, that's pretty breathtaking compared to the top 10%, which suffers depression at less than half that rate. That's really substantial. I mean, we have a huge amount of research going on in this world on sex differences in depression. And there should be research on this because there are marked sex differences with women more vulnerable than men through most of the lifespan. But those differences are smaller than these SES differences, and there's a lot less research on that. So this is, to me, a stunning piece of evidence that, poverty creates real suffering. In terms of people's capabilities, here is a graph of young adult IQ as a function of family income. In other words, their family of origin income. It's the x-axis here is number of what's the word I'm looking for? How many times you have to multiply the income to needs ratio that defines the poverty line in the US. How many times that level of income the family had, and the resultant IQ score. And you can see again, pretty big difference between people who made, less than 1 time the income to needs ratio versus more than 10 times. That's well more than a standard deviation in IQ. Okay, so poverty is a huge social problem. And so it would be nice if this research we're doing on poverty and the brain could, maybe have some benefits to people. So the question here is, what are we trying to do in this research area of neuroscience of SES? And what, if anything, are we accomplishing? So I'm going to just put up this, I'm going to put up this, kind of basic taxonomy, probably get it in every methods course. There's basic research, which is, understanding how systems work for the sake of understanding. There's translational research that takes the fruits of basic research and looks for ways that they could be developed into applicable solutions. Many times it's, commercial products, but in this case, applicable solutions would be, poverty policy or other kinds of policies that would reduce the suffering of low SES. That leads to applied research, and finally, yay, solutions to our problems. So, I want to pause for a moment and ask you, if you're working on the neuroscience of SES, definitely I'd be interested in what you think, where you think your work fits in. If you're working on anything that has any kind of conceivable long-term application, and when you're applying for funding from your government agencies and private foundations, you're saying somewhere, that this will lead to, useful solutions. And I just want to point out, maybe a little bit anticipating some of what I will say later, that it's not always easy to know what is going to end up being useful and what's not. In addition to this critique this caveman is receiving, Michael Faraday used to give these lectures at the Royal Society in London, and he did demonstrations of these electromagnetic, interactions. You could make, a wire turn by running an electrical, inducing electrical fields with magnetic fields. And he was asked by some distinguished member of the audience, but what good is it? And of course, this is the basis for electric motors, and they're all through our house and more. Okay, so I think in SES neuroscience, we have a bit of an identity crisis about why we're doing what we're doing. So are we doing basic science, understanding for its own sake? understanding the effects of the environment on brain function and so forth? Are we aiming for eventual applicability? Or do we think we've actually already got something actionable to contribute? And I will say my hands go up for all three of these, but obviously much more cautiously for the third. I can't believe that nobody hopes that this will eventually be applicable. So let's take a look at the science so far and see, how far away we might be from defending those three positions. And I want to say this is going to be basically a science-free talk. I hope Jamie isn't thinking now she tells me, but I'm going to basically just summarize kind of what we know, what we found for the neuroscience of SES. There are a bunch of good review papers out there if you want to, learn a little bit about it later, but it's a big enough field now that it really cannot be summarized in a 1 hour talk. And then, of course, that would crowd out the reflections that I want to try to take us through here. So what do we know so far? Well, there are structural and functional correlates of SES in the brain. They have relevance to SES-linked psychological outcomes. Why do I go to the trouble of making that a separate bullet point? Because some critics of neuroscience hype say, who cares if it changes the brain? We're not going to feel like we've done a good thing if we simply change what the brain scans show of poor children. We want to impact these psychological outcomes, their psychological well-being, their capabilities. So the point I'm reminding you of here is that these structural and functional correlates of SES do have relevance to real-world psychological outcomes. They are, to a certain extent, predictive. They, in many cases, have been shown to mediate the SES psychological outcome relationship with the brain differences in the middle. And this work is beginning to show some rudimentary insights into the causal pathways by which SES, and in particular low SES, impacts brain structure and function, and thence onto psychological capabilities and well-being. Okay, so there's one more thing I want to say. Actually, there's a lot more things I want to say, but I don't have time, so I won't. But these effects change over the lifespan. There are sensitive periods. There seem to be sensitive periods. How well have we nailed that down? Basically, not at all. Because, if you think about when you're working with humans in real world socioeconomic contexts, a kid who's in poverty at age 3 is probably also in poverty at age 12 and 18. There is a lot less what's called social mobility than anyone would like. So that there are some natural experiments where suddenly people get money. But basically, it's very, very hard to nail down these lifespan sensitive periods, genetic effects. It's considered kind of, blaming the victim to say there could be genetic aspects of these outcomes. I would rather take this conversation move it out of the realm of blame and credit and, and just say, what's going on here? And what does it tell us about how we can make people's lives better? Anyway, network differences, we need to not just do blobs, here and there, but functional networks, structural networks, molecular networks. And finally, I gotta say that, this area of neuroscience has replicability issues, just like every other area of human neuroscience. That's something we got to think about, but no time right now. So skipping on. Policy implications. Are there any? This is kind of the heart of what I want to get into here. Well, I'm going to say there are neuro enthusiasts who think, yes, by revealing the neural substrates of these SES differences, we are going to be able to shape policy in a useful way. There is neuroskepticism that says basically, bah humbug, brain schmain, help people by, giving them money, giving them education, moving them into better neighborhoods, whatever. And the brain is just decorative in this work. Don't, why should we care about the brain? And finally, there is what I am going to call neuro nuance that I'm going to sort of argue for here. So let's first look at neuropolicy enthusiasm. There you can find a lot of writing. Interestingly, by and large, not for other neuroscientists, but for certainly for policymakers. And by policy, I mean something very broad. I mean, educators, not just legislation, but judges and attorneys. What's a good way to bring in brain imaging evidence? What's not a good way? Basically, policy is not just laws. So these are writings for people not doing neuroscience, but interested in neuroscience, trying to do something good for the poor. And, they are, they've got some, they make some good points. I will say that most of what they say has nothing, in fact, to do with neuroscience. There's a lot of superfluous neuro talk. It's a little like, I think there was some vicious theater reviewer or book reviewer, in the days of Dorothy Parker and, all these wags, who said, this book is brilliant and original. Unfortunately, the parts of it that are brilliant are not original, and the parts that are original are not brilliant. So, I think this is kind of the case with a lot of neuropolicy enthusiasm. The parts of it that are good, we should take poverty into account when we're teaching. We should invest in early childhood. Those are good things, but they're the equivalent of the brilliant book review, but they don't really hinge on neuroscience. Okay. So basically, I am saying let's not go overboard and think that right now we have some actionable science that is going to help anybody. Then again, there's the skepticism, which I think clearly throws the baby out with the bathwater here. This includes the bell curve, which, is kind of old now. I think it came out in the 90s. but the idea behind it was, these differences are innate. There's not much you can do, if anything. And more recently, Charles Murray has questioned the relevance of neuroscience to the project of improving the lot of people at the bottom of the SES totem pole. The John Brewer, some of you may know, a philosopher of science by training, led the McDonnell Foundation for many years, including, really helping instigate cognitive neuroscience. But he wrote this book saying the neuroscience that is supposedly relevant to improving child development, including child development in under-resourced situations, it's just irrelevant. It's just fancy talk. So here is a quote that I find very, it's clever. He's a smart guy. He says, he's talking about the White House summit that the Clintons held to present the policy implications of developmental neuroscience. And he said, at the conference, I heard numerous wide-ranging policy recommendations based on the new brain science. Yet I had heard relatively little brain research, none of which I could comfortably describe as new, and none that provided a clear link between blind kittens and welfare reform. And of course, what blind kittens, that's a reference to Colin Blakemore and, many people subsequently. Could it be true, he says, that if we understood the new brain science and acted on it, we could solve social problems ranging from infant mortality to unemployment, to low intelligence, to urban violence? Based on what I had heard at the conference, my answer was highly unlikely. Okay. So, basically, if you overclaim, people slap you down. Sally Satel, an interesting, conservative commentator, physician, has also critiqued the overly large claims made for neuroscience for policy. Okay. Finally, make sure I'm okay on time. Yeah. I have to say none other than my colleague at Penn in the law school, Amy Wax, who some of you may know of. I don't know how much of this gets outside the US, but she's a very controversial figure. And try not to take this too personally, but she did write a paper called The Poverty of the Neuroscience of Poverty, Policy Payoff or False Promise. And, she's a very good, clear writer, except when she, I think, in my opinion, takes leaps into non sequiturs that are most compatible with her politics. She raises a few points here. First of all, she says, look, if you find these brain differences, they could be genetic. So what can you do policy-wise for a genetic disadvantage? Okay, so the claim is, it's called social selection. Poor people are genetically predestined or genetically inclined to have lower IQ, poorer mental health, and because these things are genetic, they pass them on to their kids. And these differences show up in the brain, but it's nothing to do with the environments that they have been raised in and they continue to live in. Okay, so she's making that point, which is also a very Charles Murray point. And the reasoning goes, which is, in my view, a total non sequitur, if they are genetic, then they're immutable. So there's nothing you can do, right? Well, when kids come to, CHOP, Children's Hospital of Philadelphia, with they've got hemophilia, okay, very serious, life-threatening genetic disease. The doctors there do not say, oh, I'm so sorry, but this is a genetic disease. So, go away. We're going to treat people whose, diseases have environmental influences. No, that's ridiculous. PKU is another very serious disease, causes serious mental retardation. And it's genetic. And if you adapt people's diet appropriately, they grow up normally. Okay, there's lots of genetic problems that have environmental solutions. And the idea that if it's genetic, then they don't deserve to have their challenges helped is, again, in my mind, a non sequitur. Another criticism of Amy Wax and others, she comes out most clearly and strongly for it, is that the neuroscience makes no unique contribution. There's no special insight that comes from neuroscience that we didn't already know from something else. And finally, that there's no actionable information. Okay, so she has thrown down the gauntlet. Others certainly echo this very famous paper by Arthur Jensen. Compensatory education has been tried, and it apparently has failed. Social class variations in intelligence cannot be accounted for by differences in environment. The science has changed, but there are environmental influences. And again, I'm not sure even what the relevance of that is, but okay. So I am going to just go through unique contribution, special insight. Okay, this is something that I want to raise because I will agree at this point that neuroscience has not taught us anything about the effects of socioeconomic status on the brain, or in more theoretically neutral terms, the correlates of socioeconomic status and the brain. That is unique, that we do not already know, or that we could at least have gotten, we couldn't have gotten some other way. God, that was a bad sentence. In other words, not only does it have to have first come to our attention by neuroscience, but that neuroscience would be the only way to understand this effect of neuroscience-brain relation. So I guess my comment to that is, this may be an unrealistically and kind of illogically high bar. First of all, for policy, typically we are looking at what's called the weight of the evidence, right? It's not like somebody runs out of the lab saying, oh, I discovered something and it's significant at p less than 301. So quick, let's rush to Congress or let's rush to the school board or something, right? You don't make policy based on exciting singular findings. That would be kind of crazy. So what gets you on the cover of Science magazine is something new and surprising that we didn't know before. It's a singular finding that changes the way we think about things, encourages us to do additional research, following up on it, etc. But what constitutes evidence for policy is an accumulation, the combined weight of evidence, as exemplified by these two magazine format publications. So I am going to just move on here, and I think I'm going to actually, well, let me just throw this all up for a second and say, you know, I think there is potential, and this is where I put my hand up for the second bullet point. I think there is potential for neuroscience to deliver actionable information. For example, there is work by, she has three names, and I am never sure whether the middle one is part of the, but Demir is the final last name of the researcher. She's done a lot of very interesting work finding qualitative differences between SES and, or between brain effects and behavioral performance effects, if you will, that are, and it's SES that determines that brain behavior mapping. So, for example, we might, well, one of her very interesting findings is that for mathematics, you know, lower SES kids typically do less well than higher SES kids. But even holding constant the difference in performance, or finding higher SES kids who are not so good and lower SES kids who are good, and looking at them with performance equated, she finds that it's verbal parts of the brain, I'll say, you know, she does a verbal localizer task, and finds, maybe botching this up, but I think, you know, that sort of peri-sylvian on the left activation, that activation is predictive of how well higher SES kids do their math problems, but it is not predictive of how well lower SES kids do their math problems. Conversely, spatial areas, activations, whatever, you know, right parietal, are predictive of how well the low SES kids do, but not of how well the high SES kids do. In other words, they're really, you know, if you open the hood, you see differences in the way kids learn math at lower and higher SES. Well, this has really important implications for like policy. If you're designing a math curriculum and you have, you know, splendid results from the kids at the, you know, Stanford, you know, lab school, or something like that, right? Kids from very high SES with lots of educational attainment in their background. An intervention that works really well for them might not work well or at all for kids in the inner city, and vice versa. Some teaching method that's been trialed in very poor schools, you don't necessarily, if it looks good in that context, you don't necessarily want to bring it to the Stanford lab school. Okay, there's biomarkers, which are really important, everything from, you know, EEG biomarkers, as Kim Noble recently used with an income intervention study. This is really useful when you're studying very young kids, when they can't talk to you and they can't listen to instructions and push the right button, right? So that is useful, potentially very useful for not just research, but screening and prediction when you're dealing with nonverbal kids. Okay. And then windows of opportunity for protecting brain development. I mean, I have to say, the literature on prenatal effects of stress, psychosocial stress, which we know is highest in low SES moms, the literature on toxin exposure prenatally shows huge effects. And now, ideally, we would live in a world where we can say, look, toxins, stress, all these things, people should be protected for them for their entire lives, right? But a much easier and more realistic approach might be to say, okay, well, we know, the second and third trimester are really crucial to protect against these things. Maybe for that period of time, it would be realistic to try to get, stress support, filters, air filters in an apartment, whatever, to improve the environment to protect brain development when the brain is first being put together. So these are just examples. Farther out, I would say, manipulations of epigenetics, manipulations of critical periods, which is now the topic of, great progress research in animals, but no reason to think it won't eventually be ready for human use. The microbiome, which I'm sure everybody is aware, is kind of like the cool the cool subject, and it looks like there are effects of the gut microbiome on brain function and psychological function. And furthermore, we know that low SES individuals have, on average, a different microbiome from higher SES individuals, presumably based on environment and diet and so forth. So I think we can say maybe eventually some of these things will deliver actionable information. And right now, I guess the watchword is, patience. I mean, think about autism research. Think about how long people have been doing research on autism and the brain. Think about how many people are doing research on autism and the brain with how much funding. Obviously, if progress is, if we want to demand actionable results in order to believe that a scientific approach to a social problem or a medical problem is valuable, then, I mean, what new cures for autism have come out of neuroscience? What new enhancements of life for people with autism or their parents have come out of neuroscience? I'm not on top of this area. There may be some things, but it's certainly nothing that has made it onto my radar screen, so it can't be, that big a success. So I kind of think, look how recent research on SES is. Look how little funding there is for it. I mean, my early research was all done, kind of essentially on the QT, not telling NIH what I was really using for funding for. Now, of course, there is funding that's advertised for, for SES, but it's very early days. So no reason to say, well, what have you shown? What have you done for us? That's ridiculous. And of course, there are a lot more poor people in the world than people with, most common neurological diseases. Maybe Alzheimer's would be an exception. I don't know. Anyway, okay, I want to go to conclusions. So we have some time for discussion. First of all, I guess this is relevant to what I was just saying. This is a young science. It will, of course, be a long game, like any other biomedical research area is a long game. So we got to proceed with patience. Second of all, there is some well-meaning overreach. People who just think, wow, neuroscience has now shown it. This is going to be, we've opened the hood. We can now see like what we need to fix. Well, not really, not yet. We can get convergence on conclusions from other social science, psychological science findings. But, it's not the case that, until neuroscience came along, we had no idea that stress was a damaging factor in the lives of the low SES people. Okay. And then, of course, because of the overreach, there's been backlash. Academics love to back and forth. And, there have been, okay, so I will say that neuroscience, I believe, has already made modest contributions. I'll use as an example of this the work that Greg Duncan, who is an economist who has long worked on socioeconomic status and capabilities, mental health, socioeconomic success, sort of knock-on effects to the next generation and so forth. He, assisted by many wonderful researchers, including Kim Noble from Columbia University, who's the neuroscientist on the team, have set up a randomized intervention giving poor mothers of newborns either, I think it's $300 a week to use as they will for 3 years, or $20 a week to use as they will for 3 years. So the $20 is obviously, a control condition that matches in many ways the big money condition, except that it doesn't really have a substantial impact on the things that money can buy in their lives. So Kim has been following these kids, and in the early checkups, she has done EEG to look at the impact of getting this money, this free money that mothers, they trust mothers to spend it on what it needs to be spent on. And they can follow that up, and not surprisingly, mostly they do. She has found effects on infant EEG that are consistent with what you see in children at that age longitudinally who go on to do better in school. So again, this is an age, I think maybe it was the 1 year, possibly the 2 year, in any case, too early to do any kind of meaningful behavioral testing. But the neuroscience gives us some insight into the likely success of this intervention. So I would call that one of the modest contributions. And then I would also point to the future potential. Okay, so now I'm going to thank you. I'm going to call your attention to the SES Neuroscience Network. It's been a kind of slow ramp up, mainly because I've been slow ramping it up. I've been working with Sebastian Lapina from Argentina, and we're just trying to get people together and get them in conversation about SES and neuroscience, educate each other. We had a wonderful online workshop on inflammation, SES in the brain, and we're in the process of organizing another one on language, SES in the brain. So please check us out online, and I thank you very much for your attention, and I would love to hear your comments and questions.
Thank you so much, Martha. That's really thought-provoking. So I got some questions, and I can see we're getting some online. Maybe if you want to stop sharing your screen as well. I'm not sure we'll necessarily go back to it. So first of all, we've got a question here, and that's, should SES research focus on human models or try and reduce the SES components such as stress and nutrition and so on and focus on animal models?
Yeah, great question. Well, so animal models have a huge advantage, namely you can do experiments, right? So you can randomly assign the rat pups or, whatever, to the good or bad nutrition condition, for example. You can't do that with humans. So that's a huge strength. A drawback is obviously that rats do not have socioeconomic status. And one thing that I didn't mention that maybe I should have is that, SES is a broader concept than just money. Are you poor? Are you rich? Are you somewhere in between? It turns out that a lot of other factors co-vary in this world with how much money you have. It's not a perfect correlation of 1.0, but it's a substantial correlation. Goes with things like educational attainment, what kind of neighborhood you live in, what kind of occupation you have, and so forth. And those are things that we can't test with animals. But I do think that, to the extent that we can make reasonable conjectures about what some of the active ingredients in the environment, the experience of a poor human being are, like nutrition, like stress, like environmental toxins, and so forth. Yeah. Animal research could be really useful.
So another question is, in terms of the structural and functional correlates or biomarkers, which would you say are kind of the ones that are the most reliable? If you were to list them, is it, I don't know, the amygdala or particular network properties or cortical thickness or?
Yeah. Oh God. I mean, I should have an answer to that. I'm actually just now starting a meta-analysis on just hippocampal volume with a few people in my lab, Hannah Howe, a postdoc, leading the way. And there is so much variability. I mean, if you held a gun to my head and said, you've got to predict and predict correctly, what correlates will really stand up, I would say hippocampal volume, but there's plenty, namely smaller volume with greater economic disadvantage or socioeconomic disadvantage. But there are lots of findings that contradict that too. There's got to be some other factors at play here that are moderating this. I mean, one reason to do the meta-analysis is to see if we can identify moderators. I think total cortical surface area is, it's correlated in a positive direction with SES more often than not. Cortical thickness, I think maybe less reliably, but certainly not the case that low SES ever has bigger cortical thickness. Oh my God. I mean, so I just finished an analysis with some economists They call themselves gene economists at the University of Amsterdam, who use their fancy economic math, econometrics, et cetera, to make sense of behavioral genetic data. And we looked at the UK Biobank. And I think in the end, when we eliminated people for this reason and that, we still had well more than 20,000 middle-aged and above adults with MRI. And we did voxel-based analysis. What we found is that basically everywhere in the brain is correlated with SES. I mean, there's a huge number of locations. And, when you control for whole brain size, obviously you're not getting as many, but the effects are very widespread. We were just looking at volume, unfortunately. So I think surface area and thickness might add useful new information because they sort of point to different processes. But basically big effect overall, composed of many, many small effects all over the place.
Okay, thanks. Yeah, I think that just answers another question that we've got about whether it's reasonable to expect localized differences as opposed to global. I think it's probably a bit of both. I mean, I've got a question around, I suppose, how you measure SES, and in particular, whether it is to do with absolute SES, or is it something to do with income inequality? So there's a whole literature showing that societies that are more unequal, so that's the difference between the richest and the poorest 10% or whatever it is. So America would be one example of that these tend to lead to more problems in, for example, violence and I think maybe mental health. So that would be one thing about this. And I suppose if we think about it over time, is that poor low SES people now, obviously they might need help and support, but if you go back 50 or 100 years ago, they're still doing better than them. So is it the case that arguably, is it the case that all of our brains are kind of richer? So in intelligence, there's something called the Flynn effect. And that's the idea that everybody's intelligence has gone up over time. You could certainly make the claim that everybody's standard of living has gone up over time, but we know people aren't necessarily more healthy. So what is it that's going on here? So what is income inequality and what is this kind of drift for everything to get better over time historically?
Yeah, well, everything drifts better over time, except to different degrees at different levels, right? So the super wealthy, the masters of the universe, get much, much better, at least if you're measuring in terms of, income and, there's, I don't know what it's like outside of the US, but there's a lot of concern that the elite colleges are full of wealthy kids from elite homes, and more so, I just read recently in the newspaper, more so now than, last century. So, so I'm basically just echoing, these disparities, inequalities make a difference. I know they make a difference in terms of health outcomes. I feel like I read something recently that addresses this. So anybody who's curious, maybe, get on Google Scholar or Medline and do a search. I'm going to do that myself later. Because, part of it is, not having enough money to buy nutritious food, whatever. But part of it is, I don't know, not being able to go to the zoo because the zoo price is in Philadelphia. We have a very nice little zoo. I don't know how people afford it. It's like $20 for an adult and then correspondingly less, for kids. That's out of reach, right? And that's a place that is stimulating and fun and invites conversation between parents and children. And so I don't think the market would bear $20 zoo admissions, in 1970, or, even adjusting for inflation, right? But because there are these, 1%ers and 5%ers with such economic means, there are these market forces that then close people at the bottom out. I didn't say that very succinctly, but yeah.
Okay, and one final question is, I suppose I do call it neuroskepticism or whatever, but just kind of, I suppose, push back on that a little bit, that the poor neural functioning must somehow also cause poor SES. I mean, it can't be the whole story, and it doesn't necessarily mean that that's a defeatist position, but there must be something in that direction.
Yeah, well, you're a brave man, because, I will tell you that I have colleagues that, I think that's right. It's kind of like, it's almost syllogistic, right? If you're better able to get what you want by being smarter, by whatever conventional measure you want, by being emotionally more, kind of stable, cheerful, whatever, it's how could it not be that there is a selection process? Okay, so now I'm being brave too. And I have colleagues who really think that that's wrong, but I don't see how they can think that that's wrong, because it seems illogical. It seems to me it's good evidence that both genes and environment enter into these differences. And in fact, with my Amsterdam colleagues, because they are, wizards at analyzing genetic data, we looked at the voxel-wise maps of SES, and then we subtracted the voxel-wise maps of the polygenic score of SES. And it does decrease some of the effects. And we assume that what's left over is probably mostly environmental, but it decreases some of the effects. What's interesting is it decreases them more in some areas than others. So for example, the insula, which is clearly like important for emotional well-being and all kinds of other things, that seems to be under substantial genetic control, because that the effect size, the SES effect size on insula volume is really knocked down by doing this genetic control. Whereas, take another area, the cerebellum, which of course is, we now recognize, is a very underappreciated and important part of the brain. The cerebellum is barely changed by doing a control for the genetics of SES. So, that's interesting. So there's got to be some of both going on. And again, making the connection between that and policy, what does that call on us to do? I think there's a lot of, it's not really clear what it calls on us to do, because again, we don't say to the little baby hemophiliac, get out of here, that's genetic, So.
Okay, I'm going to end the stream there and thank the audience for coming, and thank you, Martha, for such an interesting talk.
Well, I thank you all. Thank you.
Okay, so we can still chat.